Hi, welcome back to this channel. We are going to start another new chapter, which is thermochemistry. In this video, we only cover the subtopic of concept of enthalpy, and there are 3 learning objectives in this video, which basically is covered in lecture. So basically, what is the thermochemistry? Thermochemistry is a study about the heat change in the chemical process. Let's check out what is the meaning of thermochemical equation. So basically, thermochemical equation is different from chemical equation. So what's the difference between these two? So let's check this one. So the example over here, equation 1 and equation 2 are thermochemical equation. Okay, so when you check with what's the difference between the thermochemical equation and the chemical equation, basically is the delta H here, the enthalpy change of the energy. So means that in the thermochemical equation, as just now we mentioned that thermo is referred to the heat change. So that means you have to show the heat change in the equation, then only this equation will consider as thermochemical equation. So now, once you look at the equation 1, A plus B produce C, okay, and then C will produce A plus B. So basically, you can see that these two are the reverse reaction. So it's the first reaction need to absorb the energy. So the other way around means that it will release the energy. The magnitude of the delta H will be remain the same, only with the different sign. Okay. Let's look at a more concrete example. For the reverse equation, the magnitude or the value of delta H will be remain same, but the sign will be changed. Okay, for example, if this one liquid water, liquid H2O, which is water, when convert to ice, which is in solid form, will be released 6.01 kilojoule. But if the other way around is the solid H2O, which is ice, melt to form liquid H2O water, so the value or the magnitude of the delta H is still the same, 6.01, but the sign of the reaction will be different because one reaction is release energy, the other way around will be absorb energy. Besides from that, if the thermochemical equation is multiplied by a factor, so the delta H also will be multiplied by the same factors. So for example, if we melt 1 mole of ice into 1 mole of water, so we need to absorb the system need to absorb 6.01 kilojoule. But if now the system going to melt 2 mole of the solid H2O, 2 mole of ice, so that they can form 2 mole of water, so the energy change will be increased by 2-fold, which will become 12.02. So let's say now if here you want to melt 0.5 mole of H2O solid, so the enthalpy change will equal to positive 6.01 divided by 2, which will equal to 3.01 kilojoule. So that means always if you want to find the delta H, once the factor or the coefficient in front here is different, so we have to multiply with the coefficient. Okay, so as we already know, there is exothermic process, at where it means the energy is released from the system to the surrounding. So the potential energy of the product will be less compared to the reactant because part of them already released to the surrounding, and the delta H will be equal to negative. Previously, when we in chapter reaction kinetic, chapter 8, when we draw the energy profile diagram for exothermic reaction, we will draw like this. which we will able to show the activation energy. However, if you think that the question is chapter thermochemistry and ask you to sketch the energy profile diagram, you actually can sketch this energy profile diagram, where you also, as usual, you have to label the enthalpy for the y-axis, reactants, products, and also label the delta H with negative, which show that it is exothermic process without showing the activation energy. Okay, so the other one is having the activation energy. For sure, we also will discuss about the endothermic process. So endothermic process is a process at where the energy going to absorb by the system. So then the product, the enthalpy of the product will greater than the reactants, and the delta H will equal to positive. So at the previous slide, so this slide also showing two energy profile for you. One is with the activation energy and the other one is without the activation energy. Okay, so I think you look at the words enthalpy in the previous slide. So basically, what is the meaning of enthalpy? Enthalpy is the measure of the heat content. So heat is one type of the energy. So basically, we can simplify as the meaning of enthalpy is equal to heat energy. So later when you look at the question, you will notice sometimes they will mention about standard enthalpy of reaction. Sometimes they just mention enthalpy of reaction. So then what's the difference between standard enthalpy and the enthalpy again? So basically, if you look at the table here, when there is the term standard enthalpy, we have to consider that this reaction basically is happen in the standard condition. So what does the standard condition mean? It is 298 Kelvin or 25 degrees Celsius, and then the pressure is 1 atm. However, if the question didn't mention about standard enthalpy, they just mention enthalpy of reaction, means that it is at the stated condition, okay? Or we mention that heat change that measure at constant pressure, or you can say at stated condition. So the delta H, as we already know, it will be always is the sum of the enthalpy of products minus the sum of the enthalpy of reactant, so that whether you will get positive value, which will means that it is endothermic process, or if the calculation show negative value, so we know the process is exothermic process. Okay, let's answer the tutorial question number 2 together. Consider the following reaction. Given the enthalpy of reactants is 60 kJ per mole, product is 105 kJ per mole, and then the activation is 65 kJ per mole, respectively. A. Draw the energy profile diagram for the reaction. So if you still remember, previously mentioned that in chapter thermochemistry, basically we can draw the energy profile diagram without showing the activation energy. However, in this question, the value of the activation energy is given. So means that we will prefer the energy level diagram, which can show the activation energy as like this. So y-axis potential energy in the unit of kilojoule per mole. X-axis is the reaction progress. Then you have to label the reactants and also the products according to the chemical equation. If you don't want to use the term potential energy, you also can use the term enthalpy. Okay, next, because from here, you can label the enthalpy for the reactant is 60, while the enthalpy for the product is 105. So that's why you know that this is an endothermic process. Okay, so and then you have to label the activation energy, which is from the reactants to the activated complex. So 65 kilojoule per mole. And then next, you're going to label the delta H. Okay, so here. So all the green color that I circle will bring you 1 mark. Okay, green color 1 mark. So and then this one, yellow color which I highlight, also will be have another 1 mark. Or maybe this one I change a bit, so that we count like the circle, all the 4 circle 1 mark. Okay, and then all the 4 highlight another 1 mark. Okay, next one, question B. Calculate the delta H for the above reaction. So as we know, the delta H is change of energy of reactant as of reaction, change of energy of reaction. So means that we are going to find the difference of the energy between the reactants and also the product. So the enthalpy of product is 105. And the enthalpy of reactant is 60, so the difference is 45 kilojoule per mole. As this is absorbed the energy, so we can just write positive 45 kilojoule per mole. Here another 1 mark. Calculate the activation energy for the reverse reaction. So for question number C, we are going to do here. So now you need to, when reverse reaction means that the C is the reactant. So the C need to tie up to this peak. So at here is 105. Then the delta H over here, as we already know, is referred to 45 kilojoule per mole. So if I want to find out this area, so we are going to use activation reverse will equal to 65 minus 45, which is equal to 20 kilojoule per mole. So here another 1 mark. Now let's proceed to tutorial question number 1, which asks us to define and also write down an example for the thermochemical equation. So we have a few type of enthalpy that you need to know. There are many types of enthalpy such as formation, combustion, solution, also can known as dissolution. Number 4 is enthalpy of atomization. The 5th is the sublimation. The 6th is the hydration. 7th is the neutralization. 8th is the lattice energy. And then this lattice energy have 2 types. One is formation, and then another one is dissociation. Dissociation. Continue with the electron affinity, and lastly is the ionization energy. Okay, start from this slide, we are going to go through the definition for each enthalpy. So even though basically I always let the student know definition, we need to understand, that will be enough. Okay, so now in this part, I cannot say you just need to understand, but at the same time, you need to able to write the thermochemical equation based on the definition given. Okay, so maybe I think we have around 10 type of enthalpy. So basically, it may take up to 1 hour for this video. Okay, so if you feel that you are tired, then you can pause and then only you continue. So let's start with the first enthalpy, standard enthalpy of formation. If you still remember that in the previous slide, we have to mention that if you can see the word standard, means that this reaction basically is undergo at standard state or standard condition, which is referred to 25 degrees Celsius and 1 atm. So if we want to show in form of symbol, please remember that the not over here is means standard condition as well. So for the formation, basically is the heat release when 1 mole of compound. So from the term here, compound, so we know that is formed. So we know that compound will be the product formed from its element, and this element will be the reactant. So just now we have mentioned that the heat is released. So when the heat is released means that this reaction is the exothermic process. So then now let's look at here. We have two thermochemical equations here. Between these two thermochemical equations, equation 1 and equation 2, are both of them fulfill the definition of standard enthalpy of formation. So like just now we say that the compound will be the product. So basically, as we understand, compound is any substance that contains more than one type of atom. So when we look at this one, H2O, they fulfill the meaning of compound. Formed from its element, as we know, elements only can consist one type of atom. So when we look at the first thermochemical equation, even though there are two reactants, but both reactants basically they are made up from one type of atom. So hydrogen is element, oxygen also element. So means that the first thermochemical equation is obey or fulfill the definition for the enthalpy of formation. The other equation, which is equation 2, H2O consists more than one type of atom. So H2O is the compound. Therefore, second thermochemical equation is not fulfill the definition of enthalpy of formation. Next one, the standard enthalpy of formation of any element is always equal to 0. In other words, to say it is occur naturally. So that means we no need to gain or release energy to form that element. Now let's continue with the second definition, enthalpy of combustion. So because we didn't see the words of the standard, so here we didn't see the not. And then when we look at the condition here, we didn't mention that at standard condition, but we just mentioned at stated condition. Okay, so what's the definition for enthalpy of combustion? The heat release. Again, we know that this is delta H always equal to negative value. Like basically we know that combustion, when you burn something, you no matter what the things that you burn, you will never feel cold. You will always feel hot because you are the surrounding. So the heat released to the surrounding, so you will feel hot. Okay, when 1 mole of substance, so when here is mentioned substance, that's when it can be atom, can be element, can be compound. It's burned completely in excess oxygen. Okay, so let's look at the first equation that's shown here. Carbon plus oxygen produce CO2. Okay, so means that what you burn carbon in excess oxygen O2, then you will get CO2. So this thermochemical equation is fulfill the requirement of the enthalpy of combustion. Means that in this case, we only need to focus on the substance burn. So the substance burn is, this case is the carbon. So this substance must be the reactant. So at the same time, you also will notice, if I don't want to say that this is enthalpy of combustion of carbon, I can also say that this is enthalpy of formation of carbon dioxide. So when you mention about enthalpy of formation, means that when one mole of compound, which is the CO2, is formed from its element, both carbon and oxygen are elements. So sometimes one chemical equation, it can fulfill more than one definition of the enthalpy. So again, I repeat, this first thermochemical equation, it depends how you write it. If you want to mention delta HC, enthalpy of combustion, so you have to make it more clear, which is enthalpy of combustion of carbon. If you want to use the term enthalpy of formation, then you have to mention formation of carbon dioxide. So now let's check second equation. Is this thermochemical equation fulfill the definition of enthalpy of combustion? You can see here has the substance and then also burn in excess oxygen and then produce a product. But in this case, we consider that it is not fulfill the definition because in the definition here mentioned when one mole of substance is burned. But here we can see there is 2 mole of substance, so it is not suitable to say that it fulfills the definition of enthalpy of combustion. How about the third thermochemical equation? 1 mole of C2H4 react with 3 mole of O2 produce 2 mole of carbon dioxide and 2 mole of H2O. 1 mole substance is burned. So now, yes, 1 mole substance is burned. And then they need 3 mole of oxygen. Is it okay or it must be only 1 mole? Yes, for the number of oxygen, it can be any number as long as the equation is balanced because the highlight in the definition is in excess oxygen. So any amount of oxygen is possible as long as the equation is balanced. So and then the product, we can able to produce 2 products, which is carbon dioxide and H2O, also no problem. Because the question, the definition here only emphasize 1 mole of substance is burned completely in excess oxygen. So in the reactant part, one part of the equation is the substance that you burn, and then another reactant will be the oxygen. So the product can be any products or can be any compound or any element or any atoms that which is suitable. The third enthalpy, enthalpy of solution, also can be known as dissolution, will be simplified with the short form SOLN. Let's check out what is the definition. The heat change when 1 mole of substance dissolves in water. So when something dissolves in water, only physical state is changing. So the substance can be in solid, liquid or gas. But once it dissolves in water, the physical state will become aqueous. So now let's look at one condition. KCl, solid KCl, ionic compound, when dissolved in water, they will become free-moving ion. So once they become free-moving ion, so we are going to make it in the K plus and also Cl negative. As we mentioned just now, the physical state will change to aqueous. Next is the enthalpy of atomization. So let's look at here. The heat change when 1 mole of gaseous atom is formed from its element. So gaseous atom is the product, while the element is the reactant. So as just now in the enthalpy of the formation, we already have the idea that the element must be consist of one type of atom. One type of atom. Okay, and then the product must be atoms and also in the physical state of gas. Now let's check the The enthalpy of enthalpy of atomization is always positive because it involves the breaking of bonds. So sometimes maybe when you are confusing whether you need to put the positive sign or negative sign, then you can be trying to think about this. Bond breaking. Okay, so I always tell the student that when you want to jadi batu api, you going to menghasut in between two friends so that they are going to bergaduh, then you need more energy, right? Okay, so when the bond breaking means that we need energy, so the enthalpy change will be positive. So once you remember the bond breaking, so the bond formation automatically, you know that it is negative value, which we're going to release energy. Okay, so now let's check the equation, thermochemical equation. So is this first equation obey the definition of enthalpy of atomization? So for sure, we already know it is not fulfilled because the product, the physical state of the product is aqueous, but here we emphasize gases. How about second equation? Yes, we can see the product here have gases and then gases atom. So Na is the atom. From its element, the element is the Na. Okay, so this element can be depends on naturally. They can the physical state of the element is not emphasized. Okay, as long as naturally it is exists in solid, then it must be in solid. So as we know, sodium is the metal. So metal when at the basic normal condition, it will be in the solid phase. So for the second equation, it will obey enthalpy of atomization. So for the third equation, we also notice that the 1 mole of, here is 1 mole, okay, without any numbering means 1 mole. Gases, we also see the gases here. And then is atom, Cl is atom from its element. So Cl is the element in group 17. So naturally it is exists in diatomic molecule. So that's why you can see here the element is Cl2. And then we know that Cl2, fluorine, chlorine is in gaseous phase when, okay, but then you will notice that in this equation it is not balanced. If you write down Cl2, produce Cl. Because of we need the Cl, the product is 1 mole, so we're going to balance this equation using the 1/2. Therefore, the third equation also obeys the definition of enthalpy of atomization. Last equation, yes, we can see there is gases, but the iodine over here, okay, we can see the gases here, but the I2, even though it consists of one type of element, but one type of atom, but it consists of 2 atoms. So in this case, we say that we just want 1 mole of gaseous atom. So when we have 2 atoms combined together, we call this as molecule. So does not obey the definition. So the fourth equation is not considered as enthalpy of atomization. Okay, let's proceed with the next enthalpy, which is the enthalpy of sublimation, when 1 mole of substance sublime. So from here, we know that the meaning of sublime is change from solid state into gas state. So again, so now here we know that this substance is referred as reactant. Okay, so when we check over here, there is no numbering in front of the compound or the substance or the atoms here. So that means they already fulfill the first part when 1 mole of substance sublime. So all are solid state also fulfill to become the gas. Yes. So all these three basically is fulfill the requirement of the enthalpy of sublimation. But among these three thermochemical equation, there is one thermochemical equation is fulfill the meaning of enthalpy of atomization. So when we recall back the definition of enthalpy of atomization is when 1 mole of gaseous atom is formed. Okay, so means that we are going focus on a product now. So in the product here, yes, all the three thermochemical equation are showing gaseous product, but here they emphasize on the atom. I2, Na, and CO2, Na is the atom. So that means the second equation fulfill both definition, enthalpy of sublimation, and also enthalpy of the atomization. Next one is the enthalpy of hydration. So again, let's check the definition. Heat change when 1 mole of gaseous ion is hydrated in water. So from this statement or this definition, basically we have the idea that the gaseous ion will be the reactant. So again, when hydrated in water, the physical state will turn to aqueous. So for example, Na plus gases, ion with the positively charged, we know this is ion, and then become Na plus aqueous. So this is obey the enthalpy of hydration. Ion can have two types of ion. It can be cation and also can be anion. And because of this question, the definition only mentioned ion. So if the thermochemical equation is involved anion also, no problem. Anion, gases, and then turn to aqueous. So if you can, again and again, I think if you remember the definition, then you will able to write the thermochemical equation. So to spend the time to remember the formula before enter the tutorial for tutorial 2.2, 2.3 and 2.4. Next one, enthalpy of neutralization is the heat change when 1 mole of water is formed. So now here we know that the water must be the product from the neutralization of acid and base. So these both acid and base will be the reactants. So when we look at the first equation, 1 mole of water is formed from the reaction between acid and base. So the number of mole of acid and base that involved in the equation doesn't matter. It can be more than 1 mole or less than 1 mole, but as long as the equation is showing that it will form 1 mole of water. So the first equation is fulfill the definition for the enthalpy of neutralization. So second equation, when we look at here, this is 2 mole of water. So basically this thermochemical equation is not obey the enthalpy of neutralization. However, if you want this thermochemical equation to show 1 mole of water is okay, no problem. Because here have 2 mole of H2O, so if you divide by 2, it will equal to 1 mole of H2O. So once the H2O is divided by 2, then the sodium sulfate also divided by 2, so we will produce 0.5 mole of sodium sulfate, and then the sulfuric acid will be 1/2 sulfuric acid, and then react with 1 mole of NaOH, produce 0.5 mole of sodium sulfate, 1 mole of water, and then the enthalpy of neutralization, because here is negative 116 kilojoule, so which is referred to 2 mole of water. So now already left 1 mole of water. If you still remember in the beginning of the video here, we did mention that the enthalpy, the delta H or the enthalpy change will be changing based on the coefficient. So now you divide by 2, so here negative 116 kilojoule divided by 2 will be equal to 58. Don't forget the negative sign, will be kilojoule per mole. Okay, next one is the lattice energy. We still have another three type of enthalpy, and then you will notice that this lattice energy will involve in the Born-Haber cycle. Electron affinity also, and also the ionization energy also will be involved in the Born-Haber cycle, which is in the topic of 2.4. Okay, so if you still remember when we mentioned about the type of enthalpy, we did mention that lattice energy have two types. One is formation, and then another one is dissociation. So now let's look at the definition. The heat released when 1 mole of solid ionic compound is formed. So that means I need to know that solid ionic compound will be the product from its constituent gaseous ion. So the reactants is, okay, I highlight over here, the gaseous ion will become the reactants. What is the meaning of constituent here? Okay, is considered by its respective ion. Okay, so and then now you will notice that we have two groups of the thermochemical equation. One group is group A, and then another group is group B. Okay, so basically formation and dissociation is the reverse reaction. So now based on this lattice formation, the definition for the lattice formation, we know that the solid ionic compound is the product. So from here we know that the group thermochemical equation in the group A is referred to the lattice formation. Okay, because lattice formation, we can see solid ionic compound. Solid ionic compound is formed from its gaseous ion, Na plus, Cl negative, Mg2 plus, and Cl negative. Okay, so and then if you still remember, just now we say that if we want to break the bond, we will the system need to absorb the energy, but the other way round. So formation is the other way, opposite of the dissociation. So if the dissociation will involve dissociate, right? So it will involve the bond breaking. So if the bond breaking will lead to absorb the heat, so the formation will be negative sign, release energy. Second last definition for the type of enthalpy, which is electron affinity. So the heat change when 1 mole of gaseous atom gain. So from here we will get the idea that gaseous atom will be the reactants, gain 1 mole of electron. So after gain 1 mole of electron, it will turn to ion. Okay, and then the physical state is still the gases, but this ion will become the anion, which means it's negative charge. So now, for example, if the gaseous oxygen atom get 1 mole of electron, it will become O negative, because the gaseous oxygen atom first time gain 1 mole of electron, so this one we will not need as first electron affinity. Once the O negative continue to gain another electron, so this energy will known as second electron affinity. So we will notice that normally the first electron affinity is negative, means that it is the heat, while the second electron affinity, the third electron affinity, and so on. Okay, just imagine if the oxygen atom keep going to gain electron, the second electron affinity, the third, the fourth, and so on will be always positive value, which means we need to absorb energy. So why the magnitude of EA2 is greater than EA1? Okay, so EA is the short form for the electron affinity. Okay, so when the electron were added to the oxygen atom, the electron repulsion increased. Okay, so the result in the weaker attraction of nucleus towards the outermost electrons. So that when the radius increase, O negative is larger than O, so more energy is needed to force the incoming electron to enter the valence shell. So with more simple words to say, normally we say that once you already get the electron, when more and more electron is coming in, the electron repulsion will become stronger. So for the new coming electron, they need to absorb more energy. Last definition, which is the ionization energy. The minimum, which we already know the definition for the ionization energy in semester 1, chapter 3 periodic table. Okay, so the minimum energy required to remove 1 mole of electron from 1 mole of gaseous atom. So again, the gaseous atom is still the reactants. So after the gaseous atom remove 1 mole of electron, they become ion, and then the physical state will still maintain at gases. But this time the ion will become positive ion. So to remove electron, like just now we say in the Sem 1 we already know, if remove electron we need to absorb energy. So when the more and more electron that you remove, the magnitude is going to increase. For example, this one, first IE is for 740 kilojoule per mole, but the second IE become 1400. Let's proceed to the tutorial question number 3. Based on the equation, basically we know that this equation, we have nitric acid react with barium hydroxide, acid and base, produce salt and water. So this equation basically is referred to the enthalpy of neutralization, because 1 mole of water is formed from the reaction between acid and base. So how many mole of barium hydroxide used in this reaction if 224.8 kilojoule of heat is given off in the reaction? So we only have this thermochemical equation, the information here, even though we know that this is referred to enthalpy of neutralization. But in this question, they focus us about the barium hydroxide. So that's why we are going to compare barium hydroxide with the enthalpy change. Okay, so this is the barium hydroxide. According to the thermochemical equation, 0.5 mole of barium hydroxide going to need or release negative 56.2 kilojoule. So now 224 kilojoule is given off also showing negative. So negative 224.8 kilojoule. So basically, how many more of barium hydroxide is used? Sorry, I missed out the term more. So if you want to determine this one, so press the calculator and then you will get the number is 2 mole. By using the crossover multiplication method. Continue with tutorial question objective number 8. Choose the correct statement. Ionization energy is always positive. Yes, because we always mention that the definition for IE, ionization energy, is energy required to remove. Require means needed, so need to absorb heat, positive. Electron affinity is always negative. This statement is not true, as we already know for the first electron affinity, always negative value, while the second electron affinity always is positive value. So statement number 2 is wrong. Enthalpy of hydration can be positive or negative, but basically we know that enthalpy of hydration should be always negative. Okay, so that's why for question number 8, the answer will be 1 only, which is A. Question number 9, the diagram below shows the Born-Haber cycle energy for the formation of calcium oxide. So as we already mentioned, Born-Haber cycle will be in the topic of 2.4. However, it's okay, then we just try to, based on the definition that we learned, we identify the type of enthalpy first. So when we look at here, this is the physical state solid, and then turns to gas. So this one is considered as enthalpy of atomization or enthalpy of sublimation. So atomization, we need the energy. So that's why enthalpy delta H1 is positive value. Okay, sorry, we need to continue here with the enthalpy of delta H from the gaseous atom. Remove one more of gases, remove one more of electron, then become gaseous ion. So we know that this one is referred to the IE. And then this IE is first IE. So and then Ca plus, remove another electron, then will become Ca2 plus. So this one, delta H3 is the second IE. Okay, so next one, delta H4, the oxygen gaseous molecule form one more of gaseous atom. Again, this is enthalpy of the atomization. But this time we will not say this is enthalpy of sublimation because the physical state is not changing from solid to gas. Okay, next one, oxygen, gaseous oxygen atom become gaseous oxygen ion. So we know that this one is referred to the electron affinity. Since the gaseous atom is gain one more of electron, so this is the first EA, and then the O negative continue to gain another electron, so this is second electron affinity. So enthalpy of delta H7, solid ionic compound, so formed from calcium is element, oxygen also element, so this delta H7 is the enthalpy of formation, while the delta enthalpy delta H8 is the one more of solid ionic compound is formed from its gaseous ion, so this is lattice energy, lattice formation. Okay, so now after we identify all these type of enthalpy, so let's see what's the question asked for. Based on the diagram, which set of enthalpy all are endothermic? Okay, that means will be positive. Okay, so now let's go through. As we know, enthalpy of formation always is heat release. Lattice energy also same, formation is heat release. Second EA is positive. Third EA is negative. Atomization is positive. First IE and second IE are positive because heat required. Enthalpy of sublimation, enthalpy activation also positive. So delta H1 positive, delta H2 also positive, delta H3 positive, delta H4 positive. But the delta H3, yes, positive, delta H4 positive, 5 is negative, 6 is positive, 5 negative, 6 positive, 7 negative, 8 negative. So similar with question number 8, answer for question number 9 also 1 only, so is A. Okay, so basically we already finished for the tutorial question number 1 and number 2, which means question number 1 and number 2 for the structure, and objective we already discussed about question 3, question 8 and question 9. So basically this video already covered for the first subtopic, which is type of enthalpies. So I hope you really spend the time to understand the definition, because in the tutorial later we are not going to repeat quite detailed. We will direct into the 2.2, the calorimeter, and also the Hess law and so on, to apply the definition of the enthalpy in calculation. Okay, thank you for your time and see you in the tutorial class.